Hello guys, trust you're doing fantastic. In today's video, I'm going to be teaching you how to convert base 10 number system to other number system. Now, this is exactly what we want to do. A decimal system of base 10. We want to convert it to other number system. So we have binary of base 2 and we have octal of base 10. And we have octal of base 8. Then we have hexadecimal of base 16. All right, so let's have the first example. Now you can have a question like this that says 32 base 10 equal to x base 2. Find x. Now, since we are converting base 10 to other number system, all we need to do is to divide the number by the radix of the number system that we want to convert into. Now, in this case, since we are converting into binary, which is base 2, it means we need to divide 36 by 2. So 2 into 36 is going to give us 18, remainder 0. So we say 2 into 18, that will be 9, remainder 0. So we say 2 into 9, that will be 4, remainder 1. So we say 2 into 4, that will be 2, remainder 0. So we say 2 into 2, that will be 1, remainder 0. And then finally, we say 2 into 1, that is going to be impossible. So we're going to say 0, remainder 1. So in this case, we're going to take the value from bottom to top. All right, so therefore, x will be equal to 1, 0, 0, 1, 0, 0, base 2. All right, so this is the conversion from base 10 to base 2. This is the equivalent value of 36 base 10 in binary. Now, when you have a question like this, it simply means converting a number system of base 10 to a number system of base 8, which is octal. So all we need to do, since this is base 10, we just need to divide 36 by 8. So 8 into 36, that will be 4, remainder 4. So we go a second round, 8 into 4, that is going to be absolutely impossible. So it's going to be 0, remainder 4. So we can no longer repeat a third round because the final value is 0. So we need to take our result. We need to consider the remainders from bottom to top. All right, so we can easily say that 36 base 10 is equal to 44 base 8. All right, so this is a very straightforward way to convert base 10 to base 8. Let's have the third example where we're going to convert base 10 to base 16, which is known as hexadecimal number system. 16 into 36, that will be 2. We have a remainder of 4. Okay, so we need to repeat another step of division. We say 16 into 2, that is going to be impossible. So therefore, it's going to be 0, remainder 2. So since the final result is 0, it means we have to stop the division rounds. So we need to consider the values of the remainders from bottom to top. Therefore, x will be equal to 2, 4, base 16. So in that case, we can say that 36 base 10 is equal to 24 base 16. That's pretty very easy. So let's consider an example where we have a base 10 value with decimal places. Now let's have this. Let's have 38.25 5 base 10 equal to x base 2, find x. Now we're considering an example where the base 10 number has a decimal point. So in this case, we need to introduce a simple technique to solve this question. Now, in this case, we need to introduce a simple technique to solve this question. The first thing we need to realize is that the decimal value will be splitted into two parts. Now, the part before the decimal point and the part after the decimal point. Now, before the decimal point, we have the first part, right? The first part before the decimal point is 38. So we consider that as 38 base 10. All right. So we're going to deal with that separately. We'll convert this first part to base 2. So we're going to do this just like the previous way. We're going to divide 38 by 2. All right, so say 2 into 38, so that is going to be 19, remainder 0. So we say 2 into 19, so that is going to be 9, remainder 1. So we go another round, we say 2 into 9, so that is going to be 4, remainder 1. So we go for another round, we say 2 into 4, that will be 2, remainder 0. And then we say 2 into 2, that will be 1, remainder 0. And then finally we say 2 into 1, that's going to be impossible. So it's going to be 0, remainder 1. So we're going to take the value from bottom, top. So therefore, x is going to be 1, 0, 0, 1, 1, 0. So this will give us in base 2. So we can literally say that 38 base 10 will give us 1, 0, 0, 1, 1, 0 base 2. So we have solved for this first part. The second part is the part after the decimal point. So it means we're going to have 0.25 base 10. That's what we're going to get. So this part is broken such that when you add both parts, which is 38 base 10 and 0.25 base 10, it's going to result to 38.25. So this is the easiest method for you to do this. So you can quickly do this when you have a similar question like this. So all you need to do, once you have a decimal point in the value and you want to convert to other number system, all we need to do is to apply multiplication. So this part we apply multiplication. So what we do is this, we say 0.25 multiplied by 2. So you're wondering, why do we need to multiply by 2? 2 is the base system we want to convert the value into. Don't forget, we want to convert this value into binary, which is base 2. So it means we have to multiply by 2. Initially, we converted 38 base 10 to binary. What we did is that we need to divide by 2 because this is a whole number. It doesn't include a decimal point. So since this second part includes a decimal point, so we have to apply multiplication. So this is a rule. So we say 0.25 multiplied by 2. So that is going to give us 0.5. Now, in this case, the law says that we have to take the value before the decimal point. So what is the value before the decimal point is what we're going to consider. So the value before the decimal point is 0. So we're going to take 0. Now, how do we determine the value for the next step of operation? All we need to do is to say 0.5 minus 0. The 0.5 minus the 0. So that is going to give us 0.5. So we have 0.5 multiplied by 2. So that is the value we need to carry out the second round of multiplication. So if you multiply this, we're going to get 1.0. Now the rule says that we should take the value before the decimal point, which is 1. So we have to take this value to have 1. So for we to determine the value that we need to use for the next round of operation, all we need to do is to say 1.0 minus this 1. So that will give us 0. So we have 0. So 0 multiplied by 2. So that gives us 0. So at this point, we cannot continue the operation anymore because the final result is 0. So there are two conditions for you to stop the operation. When you get an output of 0, or when you have a consistent or a repeated value over and over when you perform the operation. So at that point, you just have to stop because it will never converge. So in the case of multiplication, we need to consider the value from top to bottom. So in this case, 0.25 base 10 is equal to 0.1 base 2. For multiplication, we have to consider the value from top to bottom. So therefore, in all, we can say that 38.25 base 10 is equal to, now the first value, which is this one, is 100,110. Now we have the decimal point. All right, the decimal point, we introduce the decimal point. Okay, so the value we got for 0.25 is this. All right, is this. So it's going to be 0.01 base 2. Okay, so this is the binary equivalent for 38.25 base 10. This is very easy. All right, so let's take another example that says 36.9 base 10 equal to x base 2. Find x. So all we need to do, remember the tactics we need to use. Now we need to divide this value into two parts. The first part before the decimal point, and then the second part after the decimal point. So the first part before the decimal point, all we're going to have this. We're going to have 36, and we're going to have 2. So 36, 2 into 36, that will be 18, remainder 0. We're going to have 18, remainder 0. And then 2 into 18, we're going to have 9, remainder 0. Then you have 2 into 9, you have 4, remainder 1. 2 into 4, you have 2, remainder 0. Then 2 into 2, you have 1, remainder 0. 2 into 1, that's absolutely impossible. So you have 0, remainder 1. So we have to take the result from bottom to top. So in this case, we're going to have x equal to 100,100. Okay, so this will be base 2. So this is equal to 36 base 10. Now we need to also determine the other part, which is 0.9 base 10. So what is it going to give us? What will be the equivalent in base 2? So what we're going to do, we're going to apply multiplication. At this point, we're going to say 0.9 multiplied by 2. So that will give us 1.8. Right, so the rule says that we should take the value before the decimal point. So the value before the decimal point is what we're going to keep. That is 1. Now, for we to determine the value we need to use for the next round of multiplication, so that will, to determine that, we need to say 1.8 minus 1. 1.8 minus 1 is going to give us 0.8. So we say 0.8 multiplied by 2. So that will give us 1.6. All right, so the rule says take the first value, the value before the decimal point, which is 1. Now, for we to determine the next value we need to use for the next round of multiplication, we need to say 1.6 minus 1. So 1.6 minus 1, we're going to get 0.6. So we're going to get 0.6. So we say 0.6 multiply by 2. So that will give us 1.2. Now the rule says keep the value. So take the value before the decimal point, which is 1. All right, so for we to determine the value we're going to use for the next operation of multiplication, we say 1.2 minus 1. So 1.2 minus 1, we're going to have 0.2. So say 0.2 multiplied by 2. So that will give us 0.4. So for which the rule says we should keep the value before the decimal point, which is 0. So for we to get the next value that will be used for the next round of multiplication, says 0.4 minus 0. 0.4 minus 0, it's going to be 0.4. So we have 0.4 multiplied by 2. So that will give us 0.8. So we take the first value before, we take the value before the decimal point, which is 0. So we say 0.8 minus 0. So that will give us 0.8. So if you continue this, we'll keep getting 0. So the value will keep increasing. So at this point, we can actually stop the rounds of multiplication because the value will not converge. So we're going to consider the value from top to bottom. All right. So we can say that 0.9 base 10 is equal to 11100 base 2. So in all right, so let's move to the next example where we have to consider a conversion from a base 10 number system with decimal point to a base 8 number system. So for the first part before the decimal point, we're going to have, so 8 into 185, it's going to be 23, remainder 1. So we repeat the round again, 8 into 23, so that will be 2, remainder 7. So let's repeat the round again. We say 8 into 2, that is going to be impossible, so that will be 0. So remainder 2. So we have to take the value from bottom to top. So the other part is going to be 0.4 base 10, which we want to convert to base 8. So all we need to do is to multiply 0.4 by 8. Now if we do that, we're going to get 3.2. Now the rule says that we should take the value before the decimal point, which is 3. So for we to determine the next value to be used for the next round of multiplication, we have to say 3.2 minus 3. Now if we do that, we're going to get 0.2. So we're going to multiply 0.2 with 8. Once we do that, we're going to get 1.6. Now the rule says take the value before the decimal point. Now the value is 1. To determine the next value we're going to use for the next round of multiplication, we say 1.6 minus 1. So we say 0.6 multiplied by 8, which is equal to 4.8. So by law, we have to take the value before the decimal point, which is 4 in this case. So for we to determine the next value that will be used, we say 4.8 minus 4. So that is going to give us 0.8. So multiply by 8, we're going to get 6.4. So if we take the value before the decimal point, we're going to get 6. right? So if you repeat this operation, 6.4 minus 6, we're going to get 0.4. So it means the operation is going to continue repeating the same value without converging. So at this point, we need to stop. So we take our value from top to bottom. So in this case, we can say that 0.4 base 10 is equal to 3146 base 2. So in overall, 185.4 base 10 is equal to the first value we got for 185 base 10 is, this gives us the answer. All right, so let's move to the next example, 16. So 16 into 64, that will be 4, remainder 0. So we have 16 into 4, that is going to be totally impossible. So it's going to be 0, remainder 4. So we take the result from bottom to top. So at this point, we can say that 64 base 10 is equals to 40 base 16. So that has been established. So the second part is, let's find the equivalence, the hexadecimal equivalent of 0.20 base 10. So let's get the hexadecimal equivalent of this. So the next thing we need to do, we need to say 0.20 multiply by 16. So that is going to give us 3.2. So by law of convention, we have to take the value before the decimal point. And then for we to determine the value we're going to use for the next round of multiplication, we need to say 3.2 minus this 3. So we're going to have 0.2. So we say 0.2 multiplied by 16. That will give us 3.2. By law of conversion, we need to take the value before the decimal point. Right, so we repeat the same process for we to determine the value we're going to use for the next round of operation. We say 3.2 minus 3. So we're going to get 0.2. So say 0.2 multiplied by 16. We're going to get the same value. So by law of convention, you take the value before the decimal. So if you repeat this over and over, you're going to get 3, 3, 3, 3. So we're going to stop at this point. And then when we want to consider the value, we consider the value from top to bottom. Right, so therefore 0.20 base 10 will be equal to 333 base 16. So in overall, we can see that 64.20 base 10 is equal to the first equivalent that was established. So we have 40.333 base 16. Okay, so this is the answer. All right, so finally, I'm going to be introducing you to the cheat code. Now we have a direct method of converting decimal number system of base 10 to binary number system. Now in this case, we can use a cheat code in converting base 10 number system to base 2. Now this is a cheat code. So all we need to do to find the combination of this digit that can result to 40. So in this case, we know that at this point, 40 is less than 128. So we're going to put 0 at that point. Now, if you check the next value, which is 2 raised to the power 16, 40 is less than the value. So we introduce 0. Now, if we check the next value, which is 2 raised to the power 15, you can find 40. 40 is greater than 32. So at this point, you say 1. Okay? it's on, it's available. So 40 is greater than 32. So you put 1 at that point. So at this point, we can say that 40 minus 32. So that will give us 8. Now, moving over to the next value, which is 2 raised to the power 4. 8 is less than 16 at this point. So we have to write down 0 on the 16. Now, if we move over to the next one, which is 2 raised to the power 3, we notice that we have 8. So we're going to say 1 at this point. So we say 8 minus 8. So that will give us 0. So for the remaining value, since 0 is less than 4, we're going to put 0. 0 is less than 2 raised to the power 1, which is 2. 0 is less than 2. And also 0 is less than 1. We can say that 40 base 10 is equal to 0, 0, 1, 0, 1, 0, 0, 0 base 2. So this is how you can use the cheat code to convert base 10 to base 2. So in a nutshell, you can also write this way. It's also, you can eliminate the zeros before the 1. So you can write it this way: 1, 0, 1, 0, 0, 0, base 2. All right, so this is pretty very easy. All right, so this is the end of this segment of our number system. Make sure you pay attention to the subsequent videos in this channel. All right then, enjoy this video. Bye.